So recording started. Okay. So friends, today's class, we are going to talk about a new topic, or I would call this as a new data structure, that is stack. So before I explain about stack and all, first let's see what is meant by stack, and I'll slowly explain everything. First, okay, what is meant by stack? So generally, stack is an abstract data type. So this is the new term that you might be hearing for the first time. If you are a computer science student, maybe you might have already heard this term. But yeah, so there is something called abstract data type. You should supposed to know, friends. Like what is meant by this abstract data type? So let's try to break it to two parts. One is abstract, second is data type. Okay, what is meant by data type? Data type. Maybe if you're okay, can you please tell me what type of data types that you are know? Okay. Can you please type what are the different data types that you know? Yes, very good. Somebody saying int, float. Okay, maybe Boolean data type. Yes. Char is also one data type. Yes. So these all are, so just to give as an example, integer data type. Then maybe you might have heard long data type. Then you might have heard something called float data type. Float. So and so on. So basically, again, these data types vary language to language. So maybe some programming languages might have maybe int long float, and some programming languages may have different data types. So again, these are depends on programming language to language. Okay. Now these and one more thing, can you tell me, for so these all data types, let us say they were present in maybe C language, just as an example. As I told, these data types are, they will specify what type of data that you want to store. Okay, assume just as an example, you take C programming language. So these all data types that are available in the C language. Yes. Now these data types, who defined it? Is it defined by you, or is it defined by the one who developed the language? Obviously, these data types are actually developed by the person who designed that language. Right? So that's why these data types, we are going to call it as a system defined. Okay, so these data types are system defined. System defined. Okay, which means these are these data types are given or developed by the developers of the respective programming language. Now we have something called user defined data types also. So we have something called as user defined data types. User defined data types. Now who defined these user defined data types? User defined data types. This was developed by user, which means those who are using that programming language, that fellow was developed. Okay, so can you give me some examples to this user defined data type? Okay, so whatever the existing data types that we have, maybe integer, long, float. Okay, so we are going to make use of those data types and we will create a new data type. Okay, now if you take for example int, so how many values you can store at a time? If I have one int, maybe just give as an example, if you have int a, okay. Now, how many values you can able to store here? Tell me. Only one value, right? Maybe some 10, 20, 30, 40. Again, if those who don't know about this, it's okay, friends. Let's not worry. Okay, people who have some idea on the C program language, maybe they can relate it. But if you are not able to understand, that's okay. It's perfectly fine. Okay. Now data type. So here you can able to store one. Now like this, if many integer elements, if I collect and if I put it somewhere, then can I call that as an array? Okay, Arey, I'm sorry. Actually, some power issues are there here. So it's heavily raining in Bengaluru now. So I'm okay. Can you hear me, friends, now? Okay. Yeah. Uh, So we are talking about, yes. Hmm. Yeah, so user defined data types. So for example, here, if you defined int a, so only one integer value you can store. Like that group of integer value, if you want to store, then so basically arrays, you can call array. Okay, maybe you can use structure also, structure. So these are basically user defined data types. Okay, now like what this abstract data type meaning? Now we came to know data type, system defined, user defined, but what does abstract data type? But first you should know what is meant by the word called as abstract. So what is meant by abstract in general? In general, abstract. Have you heard it anywhere? Please everyone Google it out and tell me what this abstract meaning is. Can anyone Google this abstract and what? No, don't from the programming point of view, please don't tell. Just what is English meaning of abstract? English meaning of abstract. What Google is saying, meaning of abstract. Hmm. Okay. Yeah. I got one definition that is existing in thought as an idea, but not having any physical or concrete existence. Very good. Very good. Okay. So what English definition that we have got? Any idea or a thought. Okay. Thought or idea. Okay. Existing in thought. Existing in thought or an idea. Okay. But not having any physical existence. Okay. No physical existence. Yes. Okay. Now, if you take a data type means, so the system defined data types are physically, they are existing really in the programming language, they were existing. Like when you write int a, what will happen depending upon the type of the system that you are using, those many memory will bytes of memory will be dedicated. Right. But if you add abstract to it, so okay, it is just an idea, but physically it is not present. If that has to be physically present, what we should do, we should provide some implementation to it. Okay. Now it will make sense. Now listen its definition completely. So basically stack is an abstract data type. Okay. So final its definition is abstract data type means those implementation details are not required for us. Okay. What it is serving the purpose, that is the only important for us. Okay. Its implementation, we don't care, friends. So stack is an abstract data type, okay, that serves as a collection of elements with the two main operations. One is push operation, second is pop operation. Now, how you are going to implementing the stack, that is not important. Okay, so how we are implementing, that is not important for us. Okay, so how it is implemented, how it is implemented is not important, is not important. Okay, then maybe someone can implementing using arrays. So using arrays, we can implement the stack. We can implement the stack. Similarly, we can use linked list also, using linked list also. Again, what is this linked list? We will study in later classes. So using linked list also, we can implement the stack. Using arrays also, we can implementing the stack, which means that how it is being implemented, we don't care. That is not at all important for us. So those type of data structures we call abstract data types. So as I said, stack is one data structure, obviously, but how it is being implemented, we don't care. That is why we call such a type of data structures as abstract data type. Okay, so those implementation is not important for us. Okay, now let's see, but it has some functionalities, obviously. That functionalities, we will make use of it. That functionality, we will try to make use of it. Okay, so in future, in Python or maybe in somewhere coding, you are going to study something called as OOPS, object-oriented principles. Have you heard this term anywhere? OOPS, object-oriented programming concepts. OOPS, right? So in that OOPS, we are going to see something called as abstraction. Abstraction. Okay, those who are seeing for the first time, that's okay, friends. Just to see, there is some concept called as OOPS is there. Object-oriented programming principles. These OOPS are. Okay. Now, like whenever I'll give you a simple example. I mean, this is a standard example. Many places they will use. Now, let's say when you go to the ATM machine, okay, when you go to the ATM machine, you can see there are different components that are present here. Maybe on the ATM machine, on the ATM screen. Okay, you can see like check the balance. So check balance is there. Okay, maybe withdraw. Okay, or maybe you can see something called mini statement. Last 10 transactions it will print, right? Mini statement. Like that, there are many operations you can screen on, maybe pin change, different operations you can see on the ATM screen. Okay, now like when you click on, let's say for example, check balance. Okay, so does it really show, I mean, what it shows when you click on the check balance, maybe whatever the money that is in your bank account, it will show. But does it really show what is happening beside that? When you click on the check balance, so one function call will be made to your account, whatever, from the database. So a database SQL query will be written, and from that query, the balance will be sent it out, and that will be displayed here. Similarly, when you click on the mini statement, what will happen in the back end? Something going on, but I don't know what's going on, but something is going on, and it will give you one printout. Okay, it will give you one printout. In that printout, last 10 transactions you are going to see. Like similarly, when you click on the withdrawal, what it will ask? First, it will ask the PIN number, then enter the balance. So maybe if I ask 1 crore, it won't give 1 crore rupee. First, it will check, okay, are there enough balance in your bank account? So these all things were happening on the back end. But does it really showing you what is happening inside? No. When you click on the withdrawal, it will ask your PIN number, it will ask how much amount of money, and that money is there in your bank account, it will withdraw and it will give it to you. But what is happening, it will not give you. Right? What is happening in the backend, which means the backend, what is happening is not important for us. The functionality is important for us. Okay. So in technical words, if I want to speak about abstraction, its implementation details are hidden. Okay, now its implementation details are hidden. Only you are going to make use of those functionalities. Are you getting the friends now? Similarly, in stack also, okay, how it is being implemented, we don't care. Okay, it's a functionalities we will try to make use of while solving some problems. Now we will talk more and more problems in this coming classes using stack. What kind of problems we can able to solve? Okay, now I hope now this complete slide is clear what I'm going to talk. Okay, let me simplify things. Okay, so we have something called as a stack, and that stack is containing two operations. One is push operation and second is a pop operation. How this push and pop operation are implemented, what type of data structure that being used. See, at the end, stack is also one data structure, but to implement that data structure, we will make use of another data structure. Getting na? And how they are implemented, all these things, we don't care. We just use those functionalities and we will solve those problems. That is the quick summary of this slide. Simple. Okay, next. Okay, what kind of operations that are possible on a stack? What kind of operations that are possible on a stack? So there are many operations are there, but most importantly, we should study something called as push operation. We should study something called as pop operation. Again, I will come to this slide in some time. Okay, so let me first talk about these two operations. Okay, now, so normally array, if you take now, if you take input array, okay, so maybe this array is containing some elements, 1, okay, 2, 3, 4, 5. So let's say 5 elements are present here, and assume index is starting from the 0. So number of elements are equal to 5. Okay, and any name you can give to this array. Maybe I'll do input array ARR. Okay, and the elements, let me take some elements I'm going to take here. Okay, now when I write here, let's say print array of 2. Can you tell me what is the output that you are going to get when you write like this? When you write like this, what is the output you will be getting? Obviously, you can use this array index, and using that index, you are going to get, yes, its output as 30. Output as 30. Very good. Okay. Now, similarly, let's see about stack. Let's see how this stack is being implemented. Okay. Now, since I am taking this as an array, so whichever element I want, I can go and access. That is the beauty of the array. Now in the stack, what will happen is, so stack is something, it looks like this. Now, if you want to add a one more element to this array, you can maybe create one more array, next index. In that index, you can happily add that element. Maybe array of 5 is equal to new 60. You can add it. Okay. Even after adding, let's say 60 here, okay, can I able to access this element? Tell me, can I able to access? Yes. How can you access this element 20? Simple. By writing ARR of 1, you can access this element. Which means in array, wherever element you go, you can access, no problem. But in stack, it is not like that, friends. So insertion will happen here. So here you are going to insert an element to the stack. Insert an element to the stack. Okay. And that insertion, we are going to call it as a push operation. So this terminology, please take care. So push whatever that element, you can push it inside. Maybe if I want to add a 10, okay, you can push this. Next, you can push this. You can push the 30. You can push and you can push. Okay. Can you tell me, if this is the scenario, assume this is the first entered the element, this is the last entered element. Okay, so this is the last element and this is the first element that you have pushed into the stack. Okay, now the beauty of the stack is here. So one variable will be there. So this, let me call as top. Okay, now here in array, any element you can go and access. But in the stack, if you are treating this as a stack, if we are treating this as a stack, then you have access to only, okay, last entered element. Last entered element or topmost element of the stack. Topmost element of, okay, stack. Can you tell me what is the topmost element of the stack here? What is the topmost element of the stack here? 50, right? Yes. So here, this 50 is called as top of the stack. Top of stack. Okay. Now, this is insert an element to the stack. Second, deletion also happen on the same end. Deletion also happen at same end, which means here only deletion will happen. Okay. So this deletion, technically, we are going to call this as a pop operation. Pop operation. Okay. So when you delete, always remember, friends, the output will be the topmost element will get deleted. Okay. See, I mean, those who are watching this for the first time, I know some of the concepts might not be clear, but trust me, at the end of the class, everything will be clear. Okay. Please have some patience. Everything will be crystal cleared. Okay. Now I'll take one example so that I'll make this concept simple. Okay. So here, consider a stack with a size of 5 elements, which means you have a stack. You have a stack. And how many elements at max you can store in this stack? 5 elements you can able to store, like 1, 2, 3, 4, 5. At max you can store 5 elements. Assume initially stack is empty and apply the following operations on the stack. Okay, what is the first operation that they are saying? The first operation that they are saying is push 10. Okay, 10 will be pushed into the stack. Okay, next push 20. 20 will be pushed into the stack. After that, 30 will be pushed into the stack. Okay, very good. First 3 operations are very easy, friends. So they are just asking you to push. Push. If I take X, what is this X? This X is nothing but element. Like whatever the element that you want to push inside that. Okay. Now, when I call this pop operation, can you help me? What is the output that we are going to get it here? Can you tell me? Is it 10 is the answer? No, 10 is not correct, friends. Always remember, when you pop this, what is the element that you will be getting? The topmost element will be deleted and the deleted element will be written here. Okay, now 30 pop. Okay. This element is gone. Now in the stack, we are having 20 and 1. Now, when you push 40, so 40 will be now added here. Okay, this is completed. These 3 operations are completed. And now when you do the push 50, so 50 will be added to the stack. Very good. When you call the pop operation, can you help me know what is the output? Remember, friends, topmost element will get deleted. Okay, which means this element will be deleted and this will be written as output. Written as output. Okay. Now, next, push 60, which means 60 will be added here. Then push 70. So 70 will be added. 70 will be added. Okay. This is the contents of the stack. Now, from this stack, if you want to delete elements one by one, can you tell me at what order elements will be printed? So I will give you 2 options. Option A, is it in this order like 10, 20, 40, 60, 70? Is this order? Or option B, 70, 60, 40, 20, 10. Which is the correct order? Very good. Option B, this is the correct order, friends. Why? Because when you taking elements one by one, okay, so you have access to this element. After that, you are having access to this element, this element, this element, this element. So this is 70. So first 70 will be coming here. After that, 60 will be coming here. Like that, elements will become like this. Okay. Like I will give you a simple example. For example, let's say, like just go back to the college days. I mean, you are already in the college days. So assume you want to take a dinner, let's say. So it's time for dinner. So everyone, let's go to the mess. Okay. So we all go to the mess to take the dinner. Sometimes we'll go outside also, but yeah. So assume, friends. Okay. So in the mess, some people will be there who is responsible for cleaning the plates. So there, some people, they are responsible for cleaning the plates. Okay. Right. So assume plates are numbered, let's say. So maybe plate number 1, plate number 2. Okay. So plate number 3, like that. Let's say total 50 plates are there in the mess, a very small mess, that is. Okay. So they have cleaned all the plates. So maybe they have kept here first plate number 1 that they have kept here. Next, they have kept plate number 2, like this, one by one, they have kept plate number 50. Okay. This is the last plate that they have kept. Now, let's say students are coming one by one. Okay. Let's say students are coming one by one. They are basically standing in a queue. So they are basically standing in a queue like that. Students are coming like this. Now, okay, let's say this student is coming outside. Now you want to take a plate, for example. Now, so from the mess worker, whoever is cleaning these plates, from their point of view, can you tell me what is the last plate that he had kept here? What is the last plate that he had kept? Plate number 50, right? First he kept plate number 1, then plate number 2, on top of the plate number 50 that they had kept. From the mess worker point of sight, this is the first plate that they have kept. Okay. Now, this is, let's say, this is from the student's perspective. Okay. This fellow, let's say, name is Rani. Okay, Rani. Now Rani is going to take plate and take the dinner and she'll leave. Okay. Which plate that Rani will take now? Tell me. Rani will take plate 1, plate 2, or which is more comfortable to take? Assume all plates are perfectly clean. So which one this Rani will take? Obviously plate number 50. Correct now. So this is entered last. Okay. So please take it. This is the plate that they have entered last. And now Rani will take this plate first. Okay. And she'll take the dinner. Therefore, the one which you have entered last is coming out first. The one which you have entered last, okay, last in, which means that is entered last, but that is coming out first. But that is coming out first. So in short, what people will call is, they will take L outside, I outside, F outside, O outside, and they'll call this as LIFO, last in, first out. Based on this principle, stack is working. They'll tell you. Now, same thing, can I call like this? Just think and tell me, friends. Can I call first in, last out? Is the both are same? Does they both are same or different? Think and tell me. Just think. Whichever plate that you have kept last will be coming out first. Is it same as saying the plate which you have kept first is basically coming out last? Yes, that is true only. That is true only, na? The plate which is kept first, okay, last May. So first time you have kept this plate. When this plate will come outside, all 49 students are taking, in last this plate will come out. So this is, both are same. So FILO. So don't get confused. Sometimes they will use LIFO, sometimes they will use FILO. Both are same only. Please do not get confused. Right? Okay. Now, okay. So I have given one question. This is previous year one of the UGC exam question. Read the question carefully and solve it. It's a good question. This is. So far, whatever explained the concept based on that only. Okay, wait. One small concept I need to explain. So basically, this is related to stack. Okay. Now, one more concept is there, that is called as queue. Okay. Now this queue, you can take it as, now let's say you want to get inside a bus. Okay, so let's say a bus is here. Now whoever comes in that queue first, that will come out first. For example, let's say this is a movie ticket counter. Let's say you want to enter into movie hall. Okay, this is the movie hall. Okay, you are, let's say, first person. Okay, maybe let's say Ravi is entered into. After Ravi, let's say Rajesh. After, let's say Sai. Okay, let's say after that Hari. So these are the people entered into a movie queue. Let's say this is a ticket counter. Okay, who will come out first? Tell me. In the queue, Ravi entered first. After that Rajesh. After that Sai. After that Hari. Who will come out first? Obviously Ravi will come out first, because Ravi entered first, right, in the queue. So this is the queue. Okay, so Ravi entered and Ravi comes out first. Okay, now let's say I want to add elements into the queue. 10, 20, 30. Okay, assume I want to enter elements like this in the queue. So remember, in the queue, one side will be entry, another side will be exit. Again, I have a separate class for queues. Don't worry about it. For example, first 10 will be go, then next 20 will go, then next 30 will go. Okay, these elements you can think of adding elements to the stack. Okay, now if I call first time delete operation, Who will comes out from the queue first? Obviously 10, right? Very good, 10. So this is the concept of queue, friends, which means who entered first, whoever fellow entered into the queue first, that fellow will come. So this is the natural phenomena, right? So whoever entered first, that fellow will comes out first. FIFO. People will take FIFO outside. So they will call as FIFO. Okay. Have you heard this term? First come, first serve. FCFS. Whoever comes first, that fellow will be served. Right. When you go to any some places, okay. First come, first serve. Whoever comes first, that fellow will be served. Something like that. Whoever comes out first, that fellow will go out first. Okay, now this is the principle of queue, friends. Now using these two, example, correct movie ticket. Yeah, something similar to. Using these two concepts, please try to solve this question. It's a good question. Yeah, what is the answer, friends? Okay, I think everyone giving B. Yeah, let me check what might be the answer. Mm, okay, there are 7 elements. The 7 elements A, B, C, D, F, G are pushed onto a stack in a reverse order. That is starting from the G. Okay, first actually they are pushing G, then E, something like that. So first we are pushing G into the stack. After that F, then E, then D, then C, then B, then A. Okay. This is the order we are pushing elements to the stack. Okay. Right. Then the stack is popped 5 times and each element is inserted into a queue. Okay, very good. This is okay. One by one, basically, they are popping, and whenever they are popping this element, immediately they were adding that element to the queue also. Very nice. Okay. You pop this element and you add it to the queue. You pop this element like that 5 times they are doing. Okay, like that 5 times they are doing. Very good. Then two element. Okay, this so far it is completed, friends. Then which means these elements are gone and they are entered into the queue. Okay, now two elements are deleted from the queue and pushed back onto the stack. Very nice. When I delete an element from the queue, can you tell me which element will comes out first? Can help me? Yeah, right? Very good. Okay. Now, yeah, like that, how many times they are doing? Two elements only. So delete this element and add back to the stack. Okay. Next, delete this element and add back to the stack. Okay. Now, one element is popped from the stack. Then the popped item will be B. B is the answer. Very good question. This is understood, friends. Read the question. Reading the question is very important. Reading the question is very important. Okay. Do you want to solve one more question? Tell me. Do you want to solve one more question kind of? Okay, just wait for 1 minute. I will put the second question also. So just 1 minute. I'll put this question. One more question I'll put it. Basically, I'm searching for a question actually. So Yeah, I found a question. Okay, this I have taken previous year gate question. This is so. Let me share my screen. Yeah. Hope you all can see my screen. You all can see my screen. Yeah. Now solve this. This is the gate question, friends. So read the question carefully and try to answer. Okay. Please don't do any calculation mistakes. Please do not do any calculation mistakes. This is the recent gate question 2023. Okay, you are too fast. Already giving the answers. So, okay. Yeah, let me not reveal the answer now. I'll wait for all the students. NQ means adding an element. DQ means deleting an element. Okay, I think I forgot to say. So NQ means add an element. DQ means delete an element from the queue. From the queue. आप पढ़ते में गेट CSC क्वालिफाई हो जाओ. Yeah, you can qualify. अब नहीं सर, only Masai. हाँ, yeah. Okay. So people, whoever is trying, you can try. I'll start the explanation. So those who are unable to solve it, please check this. Okay. I also don't know. Let me see what is the answer. Right. So listen now, listen, please, everyone. So consider a sequence of elements, sequence of A elements, which means A0, A1, A2, A3, and so on. The following operations are performed on a stack S and a queue. Okay. Both are initially empty. Very good. Okay. Let me take one stack here. So stack means always you please like this, which means one end will be closed and another end will be open. Whereas if it is a queue, both ends will be open. Okay. What is the first operation? push the elements of A from A0 to A5 in the order into stack S, which means this is stack and this is queue. Remember, reading and doing correctly is more important. Okay, first A0, then A1, then up to A5, which means first 1 will be pushed, then 5, then 7, then okay, wait, 1, 5, 7, then 8, 9, then 8, 9. Okay. Last we have 2. Okay, total 6 elements, right? Yes. Okay. First is done. What is the second operation? NQA elements A from A0 to A5 in that order only. Remember, this time they are asking you to add an element to the queue. So first element will be 5. Okay. Next element will be 5, 1, 5, then 7, then 8, then 9, and then 2. Very good. Okay. We have added all elements to the queue also. Nice. Next. What is the third operation? Pop an element from the stack. Yes. Okay. If I pop, this element will be goes away from the stack. Okay. Next. Fourth operation is what? DQ an element from a queue. Okay. Just to delete an element from the queue, which means then which element will goes out in this queue? Can you help me? Which element will goes out? 1. Very good. Okay. Because this entered first, right? So this will goes away. Very good. Now pop an element from the stack. Yes. Okay. Again, try to pop an element from the stack. Yes. Which means this will be gone. Next, DQ an element from the queue. Very good. Which means now next this element will be gone. Okay. Next, what is the seventh operation? VII. DQ an element from a queue. Okay. Which means delete an element from a queue and push the same element into the stack. So you delete this element and you push this element to the stack. Okay. Which means this element is now no more. This will be pushed back to the stack. Next, what they are asking, repeat the same operation, which means the seventh operation 3 more times. Which means you delete an element, add it to the stack. Very good. You delete an element, add it to the stack. Then you delete an element, add it to the stack. Okay, done. This is also 3 times we have done. Now, pop an element from the stack. Yes. Okay, I will pop an element. Yes, so this will be out. Then pop one more element from a stack. Very good. I will pop. This element is out. Then what they're asking, the top element of yes after executing the above operations. What is the topmost element after executing this? 8. Over. 8 is the answer. See how simple it is. It's a gate question. Gate computer science question. Right. So those who are got answer 8, you can celebrate. You can celebrate. Answer is correct. 8. So are interesting questions? Tell me. Okay, these are based on the simple concept only, friends, nothing else. If you know the concept, you can easily solve. So do you want one more question? One more question you want? Enough. Okay. We'll see more and more questions in the next classes. Now, next, let me talk. Okay, the concept. Okay, I'll come to questions, please. Now we'll focus on some concept. Okay, so you all like well aware of this concept called as list, right? Because you are studying Python from so long, so you might have well aware of this concept list. So lists are used to store multiple items in a single variable. Correct. Okay. Now lists are one of the 4 built-in data types in Python used to store the collection of data. This is important. Collection of data. Okay. So like that, we have 3 more are there. Maybe we have tuple, we have set, we have dictionary, but these are not important for us. The important thing is list is important to us. Okay. Now lists are created using a square bracket. For example, if I take ARR and if I try to write like this, then automatically this Python will understood that, okay, this is nothing but a list. Am I correct? So when you write a 1 square bracket, when you close another square bracket, it automatically understood that, yes, this is list. Okay. Now how you are going to add elements to the list? Simple, by using append operation. So here, if I want to add one element to that list, then ARR, let's say dot, for example, if I write append, then what will happen? So 10 will be, let's say, for example, if I write ARR dot append, then 10 will be added to this list, right? Very good. After that, maybe one more operation. Let's say, if I write one more time, ARR dot, let's say append, if I write append, if I write 20, what will happen? 20 will be added to this list. Yes. Okay. One more time, if I write ARR dot append 30, then what will happen? 30 will be added to that list. Okay, enough. 3 elements are enough. Now, when I do pop operation, for example, here, when I do ARR dot pop, can you help me? What is the output that you are going to get here? When I write ARR pop, can you help me? What is the output that you are getting? What is the output you are getting? 30. 30, right? So what is the beauty here? The beauty is the list in Python is working like a stack. Clear? Here, the beauty of list is, so in Python, okay, in Python, so in Python, list is working as a stack, working as a stack. Okay. Now, I want to find out size of the stack. Okay, one more time, if I write ARR dot pop, what is the output that I will be get? One more time, if I write ARR dot pop, output will be 20. Yes. So if you see, friends, initially stack list is empty. Now onwards, I will call stack. Stack and list, you can assume from now onwards, both are same. Okay, first 10 will be added. Okay, then next 20 will be added. Then next 30 will be added. When I do ARR dot pop, this element will be out and you will get output as 30. When I write one more time ARR pop, it will get 20, element will be out. Okay, now if I want to find out size of the stack, which means you can use method called as length. Okay, now can you help me here? If I write len of ARR, what is the output that you will be getting after this sequence of operations? Output will be 1, right? Yes, because now see, after these operations, initially you have added 3 elements. After that, you have done deleted 2 elements. Then how many elements were remaining? 1 element. Therefore, size of the stack will be 1 element. Now the important thing, this is the most important thing, friends. So we are going to use this frequently. Now I want to get how to print recently entered element in the list, or I can also call it as top of the element of a stack. How you are going to print in Python. Okay. So, or top of the element of stack. How you are going to print it in Python? Can you tell me what is the syntax? What is the syntax for that? Maybe this I'll explain it in the next slide. So I want to print top element of the stack. So how to print topmost topmost element of stack. Okay, maybe here I will take some elements. Let's say some elements I'm going to take. Elements are maybe 10. Assume this is AR 20, 30, 40, 50. So we already understand how to do the push operation. We already understand how to do the push operation using append method. Okay. Then we understand how to do the pop operation. Okay. By using a pop method. Now third is how to get topmost element. Okay. Top of stack. So here, the name of the stack that I have taken as ARR. Can you help me, friends? How I am going to get this element? How I am going to get this element? Tell me. Very good. Very good. Maybe I can use something like, so here, can I write length of ARR? What you are going to get output as? But I don't know what is happening. Like every time this is like this. Huh. See now. So here maybe there are many ways are there to get this element 50. So now we want to get 50 as the answer. We want to get 50 as the answer. One simple approach is you can find out how many elements that are present in this stack. So that you already know by using len of arr. This is going to give answer as 1, 2, 3, 4, 5. But indexes are starting from 0. -1 I will write. And I will keep like this, ARR. Can you tell me, does it give output as 50? Tell me, friends, does it give output as 50? Yes. This is one way where you will get the topmost element of the stack. Next. Second. But to do this, we should make sure one thing, friends. Whenever we are writing topmost element from the stack, okay, please make sure at least one element should be in stack. At least one element should be in stack. Okay, so what is correct way of writing? So the correct way of writing is, so what is the correct way of writing this? Length of ARR should be greater than 0 if this is true. Okay, then you can write print. Okay, so ARR of length of that array -1. Is it correct? Tell me now. Yes, we have checked that if stack is not empty, no, if stack is not empty means at least one element is there, then I can take that element. Okay, what is other way of writing? Rather than writing completely this, maybe you can replace this with ARR of -1 also. So in Python, you can write this also. When you write this statement directly, it gives the topmost element, but the condition should be at least one element should be there. Then only this will work. Like, have you seen this previously? You might have seen, right? Yes. If you want to, if this statement has to work means, then please make sure that list should contain at least one element. List should or stack should contain at least one element. Okay, now this is how we are going to get the topmost element of a stack. Clear? Is this clear? Okay, good. Next. Now let's talk about applications of a stack, friends. Applications of a stack. Okay, so very important. These are first application will be the first application, because this you can expect it in the interview. Okay, so please pay attention here. Okay, so first application will be function calls and recursion. Right now, do not worry about what is this recursion. This I will explain in the maybe after a couple of classes. I'll teach this recursion, but first understand. Okay, function calls. So first application is in function calls. So have you studied functions in the Python? Tell me, friends, have you studied functions in the Python? Def you will use. Okay, very good. Okay, just let's say here function f1 is there. Okay, and after some time here maybe I have written f2. After some time, okay, I have written, let's say, f3. Okay, now in the f2, okay, maybe I have f4. Then in the f4, okay, let's say I am calling F5. Okay. So assume every function inside, let's say, if it is function F1, assume that inside function F1, so print statement is there. Okay. So print statement is there. Let's say that function number we are printing. Okay. So this is not actually a complete code, but just assume inside F2, what will be there? Okay. Or else maybe we'll do one thing. Let's not worry. Now, let's try to see what is the order in which these functions are going to get executed. Okay. First, you are going to call F1. Now, whenever if any function that you call now, what will happen is a stack will be created, friends. Stack will be created. So the first function call you are calling as F1. So it will be pushed into the stack. Now it will go line by line. So in the F1, basically you are calling function F2. You are calling function F2. Now, whenever F2 call is happening, what will happen, friends? Immediately it will go to F2. Okay. It will remember something here because after completion of F2, you should come and execute remaining things. So F2, okay, now it will go here. Inside F2, after some point of time, F4 will be there. F4 will be there. Okay, now it will go to F4. And in the F4, we will be having something called as F5. F5. Okay, so let's say F5, nothing is present in the F5. So assume something is there. Now, after completion of F5, okay, so can I say that F4 is also completed? Can I say, friends? After completion of, once if F5 execution is completed, can I say that completion of F4 is also done? Can I say? No, you cannot say because some more lines are present after F5. Are you getting? See, inside F4, we are having some lines. Okay, let's not worry about what these are, some statements. And you are calling F5. After calling F5 also, some statements are present. Let's not worry what those statements are. Let's not worry what those statements are. Okay, na? Now my question is, if F5 execution is completed, which means that will be deleted from the stack, then can I say that F4 is also completed? You cannot say because some more things are present in the F4. After completion of F4, then this will get completed. This will be deleted. After the F4, how it knows that it should supposed to execute this? How it knows? Because in the stack, we are keeping something called as stack pointer. Let's not get into those much of details. Something called as stack pointer will be there. So it will point here, okay, in F2, from where it should supposed to start its execution. Which means if these also completed, then F2 will be deleted from the stack. Okay, F2 I have deleted. Then can I say that F1 is completed? Tell me, friends. Can I say that F1 is completed? No, you cannot say because in the F1, something is present. F3 is there. So which means all these three things will be deleted. And here again, F3 will be pushed. Now it will check where F3 is present. Let's say F3 is present here, for example. Then F3 will be executed. Then you can delete this from the stack. Okay. And if anything is present on the F1, you execute that. If F1 everything is also done, then this also will get deleted from the stack. So this is how the stack will be used when any function call is happened. Hope this is clear. What is happening? So simple. Whenever a function call is made, then immediately that will be pushed into the stack, and that is called as activation record. So let's not worry much about these things. In the recursion, I'm going to explain clearly. Activation record. Okay, just remember something called as activation record. This I will talk, friends. This I will talk. Okay. So activation record. This I will talk later. Okay. Right now, do not worry about much what this activation record. When I explain about recursion, so there I will talk. Next, that is the first application. Similarly, what is the second application of the stack? Something called as undo redo operations, which means, so like whenever we are, writing any text in Google Doc or maybe somewhere else, so we are going to some mistakes. If you do not, we will go back. We will go back, right? Control Z we will press. So have you all used this Control Z? Control plus Z, Control plus, I think What is control plus Y, right? Control plus Z, control plus Y equal undo, redo. So these undo, redo features in various applications uses stack only. Keep track of previous actions. Okay, so each time an action is performed, it is pushed into the stack. To undo that action, the top element of the stack will be popped out and the reverse operation will be performed. This is called undo redo operations. Third, expression evaluation. So this I will explain it in the next class. In detail, I'll talk about this. Okay, let me talk about this. Something called browser's history. Okay, so listen carefully. Something called browser's history, friends. Okay, maybe I will show practically here. Let's say, maybe I'll open, let's say www.masaischool.com. Okay, I have just to open this Masai web page, friends. I have just to open this Masai web page. After opening the Masai web page, so what is happened? So one activation record will be created here. And okay, maybe I will write it here. Okay, so I'll explain. This is the fourth point, browser's history. Browser's history. Okay, so whenever if you open any website, so immediately that website will be, okay, the URL of that website will be pushed into the stack. So which means, so this Masai URL is there now. So this will be, okay, so pushed into the stack. This will be pushed into the stack. Okay, next. Maybe I will go to course page. Then what will happen? This will be pushed into the stack. So Masai course page will be pushed into the stack. Okay. Next, let's say inside course page, I want to view about full stack web development detail. Then what will happen? The full stack web development detail will be pushed into the stack. This will be pushed into the stack. Now, let's say I don't want to see this full stack program. Okay, maybe I want to visit something else. Then if I want to go back, when you click the go back, where it should supposed to go? It should supposed to go to course section. Correct? So how it knows that it should go to the course section? Right? So here, so this item will be popped off. This will be popped off and it will be present. So whenever you click the back, so here, so we have something called as back and next. So this is back. And let's say this is next. So then what will happen? This will be popped off the stack and it will go to here. Okay. From here, for example, this time I am interested in, let's say, backend development. Now, if I click on view details, what will happen? This, whatever the backend course will be there, this will now be pushed into the stack. Right? Now, this backend course, whatever this is now gone. This is now no more. This is now no more. Okay. Now, this will be pushed into the stack. Now, can you help me? If I click the back button, will it redirect to course page or will it redirect to web development page? Tell me. If I click back here, does it go to course page or does it go to web development page? Masai course page, right? How it knows that it has to go to course page? If you click, it is going to course page. How it knows? Yes, it is already present in the course here. When you click the back, this will be popped out from the stack and it will go to the course page. So that is one practical application where stack is being used here. Understood, my friends? Understood, everyone? Okay, good. Next application is, okay, somebody raised the hand. Yeah, Ayon, yeah, please unmute and ask me out.
Sir, if the last operation is being popped, then how do we keep track of the when we press the forward button?
No forward button. This one.
Yeah, this one.
For that we have doubly linked list is there. So we have something, next classes you are going to study something about doubly linked list. This because in the stack we have access to only the last page. That's it. Okay. So there I will talk about something doubly linked list. So there it will be clear. Yeah. Okay. So this is the fourth point, friends. Next, fifth one will be the most important. Okay, you can expect questions in the interview also. That is something called as balanced paralysis. Like, what does it meant by balanced paralysis? Maybe I don't know in Python. In Python, will you make use of these symbols? Yes, you can use, right? Okay, for example, friends, now tell me, if I write ARR is equal to, if I write like this, then immediately Python will understood that this is the list. This is the list, right? In case if I miss this bracket, it will give error, right? It will give parsing error because it is not matching, right? So how it detects, there again stacks will be used. So there again stacks will be used. Now, okay, this question I will discuss in the tomorrow's class. What is the time now? Okay, now time is maybe I will take in tomorrow class. That is balanced paralysis problem. Okay. Next, one last application is nothing but a backtracking algorithms. So we have something called backtracking algorithms. This also again you are going to study maybe in the next month or after some classes. So there also stack will be used. Okay, you can please note it in your notebook, friends, because in interview they can ask, can you tell me what are the practical applications of a stack? You please note down all this. Okay, so one last point I will say and I will close the class. Okay, that is stack permutation. Okay, so this last point I'll talk and I will close it. So it's very important, simple topic, this stack. Do you need a break or I just require some 10 minutes of time? So can I explain and I'll close the class, or do you need a break? Just 10 minutes, that's it. Yeah, so please be here. Just 10 minutes. This is good question, this good topic. This is the stack permutation. Okay. Like what is meant by permutations? What is meant by the permutation? So maybe if I take, let's say 1, 2, 3, 1, 2, 3, how many ways you can permute this? So 3 factorial, right? So that is maybe first is 1, 2, 3. Then you can fix 1 here. Then keep 3, 2. Then maybe I will write it here. So 1, 2, 3. 1, 2, 3. 1 is maybe you can 1, 2, 3. This is one permutation. Then fix 1 here. Then 3. Then 2. Then fix 2 here. Then 1. Then 3. Then fix 2 here. Then this is 3. This is 1. Then fix 3 here. This is 1. This is 2. Then fix 3 here. This is 2. This is 1. So this is how these numbers can be arranged. Clear? This is called as a permutation, arranging these things. Okay. Okay. Somebody asking difference between permutations and combination. See, permutation is nothing but simple arrangement. Combination means, so their selection is important. Okay, order is not important there. In the permutation, order is important. See, these are nothing but general permutations, friends. So these are actually general permutations. So if 3 elements are there, total how many permutations we got here? 6 permutations, right? So this is the first permutation, second permutation, third permutation, fourth permutation, fifth, sixth. Out of these 6 permutations, okay, out of these 6 permutations, you should know, okay, how many are the stack permutations. We have seen permutations we have seen. Then we should see something called as a stack permutations. Okay, what is stack permutation? That I'll talk now. Stack permutation. Okay. So assume in this is the order in which elements are pushed. This is the order of elements are pushed into the stack. Let's say push 1, okay, and push 2 and push 3. Assume this is the order in which elements are being pushed. Okay. Now, wherever you want, you can pop. Maybe you can pop here. You can pop here. You can pop. Wherever you want, you can do the pop operation. But let me check. Are we going to get these ordering or not? Okay. Just see this example. You'll get the clarity. Okay. So first, I'm going to push an element to the stack. Listen carefully, friends. Okay. So first, let me push 1. Okay, so there is a stack here. So first I will push 1. Now output I am expecting 1. You have already pushed 1, then you can do the pop. You can do the pop so that you will be getting 1, which means this 1 is now not present in the stack. Okay, next push 2. Okay, next I am expecting output as 2. So what you can do, maybe you can push 2 and you can do the pop. You can do the pop. So what will happen? 2 will be pushed and 2 will be popped out. Okay, next you are expecting 3. Okay, what you can do, maybe you can push 3 and you can do the pop and you will be getting output as 3. So you can push 3 and you can pop off, so that this order is correct. So this is one of the stack permutation. These are nothing but a general permutation. So this you can call as general permutations. Out of general permutations, how many? N factorial. Okay, in that, how many are the stack permutations? Okay, remember, this is the order must be same. This is the order in which you need to push. Now let me check. So this is the order in which you need to push. Order of pushing. Okay, this is important. Okay, now next one, let me check. See, first element that I'm expecting as 1. Therefore, maybe I can push 1. Now, if you want, you can pop it off. Yes, I want 1, right? Therefore, I can pop, no problem. So I will get 1. Next, they are expecting 3. Since they are expecting 3, then compulsory top of the stack should contain 3. But can I write push 3 here? Can I write push 3 here? No. The order must be push 1, then push 2, then push 3. Therefore, here I cannot write push 3. Okay. But I am expecting here output as 3. Okay, maybe first let me push 2. Then let me push 3. Now if I write pop, can you tell me, will I get output as 3? Yes, you will get output as 3. Okay, you will get output as 3. Now see here. So in the stack, first you are pushing this one. Okay, then you are popping off. Then you are pushing 2. Okay, then you are pushing 3. Okay, and when you do pop, yes, you will get 3. Okay, next can I do pop? You will get 2. Yes, this is also one of the stack permutation, and this is the order in which you need to do to get this output. This is the order in which you need to follow. Okay, now let me check. Does 2, 1, 3, is it the correct order? Is it the valid stack permutation? I will check. Okay, first they are expecting 2, which means top of the stack should contain 2, but directly 2 cannot be there. Before 2, 1 has to be there. So there is no option. First you need to do the push 1. Okay. After that I will do push 2. After that I will do push 2. Okay. Can I do pop? Yes, you can do the pop. Okay, which means now 2 will be out. In the stack, 1 is present. Now also I'm expecting 1. Okay, you can do the pop. Very easy. You can do the pop. Now stack is empty. Now I'm expecting 3. Okay, you push it and you pop it. So you push 3 and you pop it. So, which means, so you are able to come up an order like this. Assume this is the push order. So this is also valid stack permutation. Now can I call this is the valid stack permutation? Please, you try out. Like without taking pen and paper, just to try and tell me. Don't take pen and paper. Just to tell me, is it a valid stack permutation? With your brain only, try to see. First, they are expecting 2, which means 1 will be pushed, 2 will be pushed. So 2 you can pop off. Then you push 3. 3 you can pop off, 1 you can pop off. Yes, this is a valid one. Don't take pen and paper. With your brain only, you visualize. Okay. Yes, this is also valid stack permutation, friends. What is the order? First, they are expecting 2 now. So first you push 1, because directly you cannot push 2. Why? The order is important. The order is important. Okay. First you push 1, then you push 2. Since they are expecting 2, okay, you can pop off. Then they are expecting 3, so you push 3. Okay. Then you pop, so 3 will be output. Then you do one more pop. Now again, don't take pen and paper, just to see, is it a valid stack permutation? Is it a valid stack permutation? Okay. First they are expecting 3 means 1 will be pushed, 2 will be pushed, 3 will be pushed. They are expecting 3. Okay, you can pop. Next, will you get 1? Is it possible? No, in stack it is not possible, right? Which means this is not a valid stack permutation. How? See here. So this is a valid stack permutation. First 3 they are expecting. Directly you cannot push 3. First you need to push 1, then push 2, then push 3. Okay, which means first I will push 1, then I will push 2, then I'll push 3. Okay, very good. Now they are expecting 3, so you can pop it. Happy. Now if you see friends here in the stack, so this one 3 is present. Okay, then okay, first one. So you are pushing 1. After that you are pushing 2. After that you are pushing 3. So 3 will be come out. Okay. Next to pop. Okay, first to pop 3 is coming out. In the next pop, what is the output that you are getting? You are getting output as 2. But they are saying it is 1. So it is not possible. Which means it's an invalid stack permutation. Now can you help me? Is it valid? Is it valid? Yes, this is valid. This is valid. Okay. So this is how you are going to identify the correct stack permutation. So this is clear. What is meant by stack permutation? So they will give the push order and they will give you one of the general permutation. You need to tell it is valid or not. Okay. Can I give one question based on this? Can I give one question? Okay. You take this question. Please read the question properly and try to. Sorry, 1 minute. Just a minute. Yeah, you can take this question and try to solve. Last question this is. With this, I will close the class. So this is the input sequence that they were doing, friends, which means this is the order in which they are adding the elements. First, they are adding 5, then 7, then 8, then 4, then 6. Out of this, they are asking which is the valid stack permutation. They're asking which is the valid stack permutation. Or you do one thing, don't take pen and paper, just with your brain only try to solve. It's a good exercise for your brain also. Don't take pen and paper. With brain only try to solve. And tell me which of the option is correct. Okay, very good. Already some students are giving answers also. Just do with brain only. Do with brain. Okay. Don't put on pen and paper. Which is the correct one? Correct one out of the 4 options. I think many of them are saying option D. Yeah, I think option D might be correct answer. Okay, somebody is saying even B also. Okay. Let me try. Oh, option B is the answer. Yeah. Now the push order is push 5, then okay, maybe I'll write to the push order. Five, 7, 8, 4, 6. Okay, now first let me take option A. Okay. In option A, first they are expecting 6, which means I need to push all these elements. So 5, then 7, 8, 4, 6. Okay, 6 will be yes. Next they are expecting 8. How you will get 8? Next element should be 4, right? Therefore, option A is wrong. I'll go with option B. Okay. Again, you take the stack like this, option B. First, they are expecting 6 means no other option. You push all the elements, which means 5, 7, 8, 4, 6. So first element, yes, 6. Then next they are expecting 4. Okay, yes, 4 also will be coming. Okay, you pop. Next they are expecting 5. How 5 will be coming? 8 should supposed to come, right? So option B is also wrong. Then option C. Option C. Okay. Let me check for option C. First, they're expecting 6. So no other option. You push all the elements. So 5, 7, 8, 4, 6. So you pop off. Okay, 6. Next should be 4. Yeah, 4 pop off. Next, they're saying 7. How 7 will be coming? Should be coming 8, right? So this is also invalid. Okay, the last option is option D. So let me check option D also. Let me check last option D. Option D. Okay. First, they are expecting 7. So first I will push 5, then I will push 7, and I will pop it. Okay, very good. So first 7 will be coming. Happy. Next, they are expecting 8. Okay, I will push 8, then I will pop 8. Okay, I will get 8. Then next, they are expecting 4. So okay, I will push 4 and I will pop it. Okay, 4 also you will be getting. Next, they are expecting 6. Yes, I will push the 6 and I will pop. Okay, this is also true so far. All elements are gone. Next, I will pop 5. Yes. So this is the valid one. So option D is correct. Very good question. This is only option D is correct. So got it, friends, everyone? So this is how you need to solve for the stack permutations. Stack permutations. Okay. With this, I will close this class today. So some OJ problems will be given to you. So you please try to solve those questions, and I will take those questions in the next class. Okay, now? Cool. Yeah. So thank you, friends. So anyone have any doubts? Okay, let me not end the session. Okay, somebody raised the hand. Yeah, Avinash, yes, you can speak.
Sir, I want to know about the stack permutation uses, where we can use this or where
No,
it is used.
no. Okay, actually, this stack permutations, you cannot use this to identify is it right stack permutation or not. You are going to use the stack. So this is one OJ question will be there. One OJ question will be there related to this. Okay, so
Sir, matlab, means we need to check that whether this is a correct order or not.
Yes. To check that, you are going to use this concept. So let me tell you how your OJ question will looks like is. So input they will give you. So the pushing order will be given to you. So they will give you the push order, like
Okay,
means
sir.
this one. Then along with that, they will give you one permutation. Okay,
sir.
one
Okay, sir.
permutation will be given to you. Now you need to return output as true if it is a valid stack permutation, which means like this, or you should return output as false if it is not a valid stack permutation. To check that it is valid stack permutation or not, you have to use the stack.
Okay, sir.
Yeah.
Got it.
Yeah.
Okay, sir.
Okay.
Happy Teacher's Day, sir.
Yeah, thank you. Yeah, I will share this class, friends, definitely. Just wait for maybe five minutes. So I will be sharing this class notes on the LMS. Okay, so now my part is done. Now next, I think Sayan will be taking from here and there. Okay, Albin, the Sayan is here. Okay, I'll make him as a host. Okay, make a host. Yeah, Sayan, you are host now.
Yeah, thank you, sir.
Yeah. Okay, just 1 minute. Okay, so friends, I'm dropping off the class. So if any doubts are there, you please ask to Sayan or solve the OJ problems. And the next class, I'm going to take those questions. Hello. So thank you everyone. Yeah, Sayan, you please continue.
Yeah, sure. Okay, so guys, I am sharing the DLC form. Okay, everyone please fill that. I hope everyone got the DLC form. Is it visible? Just let me know in the chat. Yeah, happy. Thank you, Amarjit. Okay, so does everyone got the form? Thanks, Saurabh. Great. Okay, so guys, please fill the form. Okay, and if you are done with the form, then you can leave.